Today we've got an interesting and colorful experiment for you, and a strange puzzle. We did receive a new and exciting package from France from our cousin today, but this isn't it. We'll save that for a future video. This is the potassium hydroxylamine disulfonate which we prepared in a previous video. We wanted to test it, and the easiest way we could think of to do that was to try to make a compound called Fremy salt. So we're starting off with 5 grams of our suspected potassium hydroxylamine disulfonate. It's a clumpy white powder and probably not 100% dry, as you can see. First thing we're going to do is try to dissolve this in a small amount of slightly warm water. We've got the beaker on a hot plate stirrer here, and a little bit of water to add. We'll use more if we need to. Okay, here's a stir bar and some water. Let's see how much it takes to dissolve. Actually, more than we thought it would given how hard it was to crystallize out in the first place. Still slightly cloudy, but mostly dissolved. So this will do. Now for our next reagent. To make Fremy salt we apparently need to oxidize the starting material. To do this we're going to use potassium permanganate. So we've weighed out 1 gram of potassium permanganate crystals. This is slightly less than we need theoretically, allowing for the fact that the starting material doesn't seem completely dry. And now we'll add some water and stir and gently warm the mixture until all the crystals are in solution. Here we go. So to do the reaction we're going to add our potassium hydroxylamine disulfonate solution to this. The mixture turns a green-blue color and there's a thick precipitate formed. We let this stir for a few minutes to make sure that everything has reacted. Let's filter. There's an intense blue-colored liquid filtrate, and what looks like a cake of solid manganese dioxide remaining in the filter. So here's the blue filtrate. It's a very interesting deep indigo color. We cover this up and chill the mixture down overnight in the fridge to see if anything will crystallize out. By the way, to clean the filter is not too difficult. Make up a dilute solution of sodium bisulfite in water and run this through the filter. This dissolves the manganese dioxide and removes the blue color. Now rinse with water. Here's our filtrate after chilling for 12 hours. As you can see there's a yellow crystalline solid starting to separate in the mixture. And after a few more hours of chilling there's a fair bit of this. So we set up again to filter this. We found that washing with a little acetone didn't dissolve the solid and got it nice and dry. Well, Fremy salt is supposed to be beautiful yellow crystals. We've got the light brown powder. 2.2 grams of a dry light brown powder. Our first thought was maybe it's a weird form of manganese dioxide. But it's quite dry and at 2.2 grams it's impossible. It's also the wrong color. So we decided to embark on some tests to see if this would give us some clues. First up, some warm water. Let's dissolve a bit. A pink, slightly lilac-colored solution, still with some undissolved particles floating around. If we add a bit more solid, the mixture turns more red in color. Okay, now let's try something else. Here's some water, and we'll add to this some potassium hydroxide to form a strong solution. Let's check it out. Weird. It's less soluble in the hydroxide solution than in water. Next up, let's try 50% sulfuric acid. Instant reaction, some effervescence, and a white solid transiently produced. The gas has a slight aroma of nitric oxides and sulfur dioxide. Concentrated hydrochloric acid. A similar thing happens, although what's interesting is that there's no aroma of chlorine gas being produced at all. So this proves beyond doubt it's not manganese dioxide. Let's do our patented standard test for oxidizing agents. We'll add some of the powder to some red phosphorus and crush and mixture together well. Let's get a hot metal pole in there and see how violent it is. There's definitely some oxidizing action, but it's relatively weak. Well, it's all a bit inconclusive. It's not manganese dioxide, it's not sodium bisulfite. It's possible a mixture of things, but it is a very interesting color. There is another intriguing clue as well. We left the mixture overnight in a small sealed bag, and when we came back the next morning, this is what it looked like. The color has changed to a white powder. There are still a few traces here and there of brown. It looks a bit like brown sugar. We figured we'd dissolve some of this in water to see if we could work out what the white powder was. There's a lilac-colored solution formed, and also at the bottom a really intense bright orange powder. And slowly, over a few minutes, the orange powder dissolves and the lilac solution slowly fades to nothing, leaving a colorless solution. Okay, well, we're going to have to print out some Kimple t-shirts because we're going to need something to offer as a prize for whoever can tell us what is going on here. Is the orange solid at the end the legendary Fremy salt? It might well be. But if it is, what was the intermediate? More questions than answers on this one. And it doesn't look too promising for our potential hydroxylamine OTC preparation route unless we can figure them out. So stay tuned and we'll see if we can find out.